All right, first thing we're going to do today, that you'll probably have some Delta Math homework on. Maybe your whole homework might be Delta Math, depending on how fast we move. We will get back in the book, so don't lose your book or however you access your book, because we'll be in it some. I like the book. But I just have good worksheets made out for this over the years, so we're doing that right now. Something that you'll see as important is this kind of nice little investigative, like you'll see what quadrant would you be in if this is true. And it really helps you like see what's going on with the interaction and everything, okay? So I would definitely, if I saw this on a test, go to all students take calculus. And if sign is less than 0, that means sign is negative. And so that narrows it down to these two, right? And then if cosine's greater than 0, I'm definitely in what quadrant?
The fourth quadrant.
Fourth quadrant. Did y'all get that just now?
Yeah.
We'll have some Delta Math to practice that. Why don't you do one without me talking? Don't tell each other, but you pick a quadrant, okay? So, don't say anything, just decide what quadrant that would be in. I don't know where to get in this room. All right, raise your hand if you know, or if you want to answer. Nazareth?
The third quadrant?
Third quadrant. Did everybody get quadrant 3?
No.
Okay, if tangent's greater than 0, all students take calculus. That means it's in one of these two. The tangent is positive. Okay? Do you see that? No?
Yeah, no.
You got that? And if sign is less than 0, then out of these two, it can't be the first one.
Yeah.
So process of elimination. All right, let's do one that's a bit harder than that. Let's say if you have cosecant of theta is greater than 0 and cosine of theta is less than 0. So I don't ever deal with cosecant, I always just switch it to sine. The only way cosecant is going to be greater than 0 is if its reciprocal sine was greater than 0. So when you encounter that, do y'all see what I mean? That's how you find cosecant, isn't it? You just go ahead and find sine, go ahead and figure out its SIGN sine, and then flip it over, okay? So I would make a little note to self that they share the sign. A trig function and its reciprocal have to have the same sign. And so you may have figured it out. All students take calculus. Sine is positive, so it narrows it down between these two. And if cosine's negative, it can't be that one, so it'd be quadrant 2. All right, so those will be on the test, so that'll be nice. You'll practice it on Delta Math, okay? Now, let's go into what else I was building up to the other day, where I almost got into it and just said I'd save it for the day to where you didn't have this like couple of days in between this profound information. Two things. It's better to measure angles in radians, which you feel like, well, then why haven't I been doing it? And I'm almost through with high school, which is a good question, by the way. It's sort of like, why am I still measuring things in inches and, yards and miles? And when I go to Europe, and the car's kilometers per hour, and the speed limit's in kilometers for the rest of the world besides me. So anyway, radians are a far better measurement. Because they really are more indicative of what's happening with the circle. And I said two things. The second thing is, your first question is, well, okay, if they're so great, why don't I have any idea what you're talking about with radians? Second of all, you've been doing it all along, like I said the other day, you just didn't know it. So it's going to be very eye-opening, okay? You're going to be going, oh my God, are you kidding me? You'll see it. All right, so here's what a radian is. I'm going to draw a circle of any size. Now when you hear people say unit circle, what that really means, they could just say circle. If they say unit circle, all that stuff that they're doing is based on a radius of 1. And that's another reason I don't like the unit circle, because the radius doesn't have to be 1. Look at the Earth. People are doing tons of trigonometry on the Earth, who has a radius of about 4,000 miles, I think. Maybe more than that. 8,000 miles. I don't know how big it is, but it's big. I have to do I don't, but people I've taught, work for different companies like Lockheed Martin, where they have to do trigonometry into outer space, where the radius is definitely not 1. They're looking at a satellite and trying to get an angle, or go and fix the satellite, so they're trying to launch a space shuttle up at a certain place. Gotta be really precise because everything's moving, okay? And so, the radius isn't always 1. And so people get hung up on that on the unit circle. So let me pause for a minute. Back, what I wanted to leave behind are special triangles. If the radius of this is 1, if the radius of this circle was a unit circle and the radius was 1, okay? And if this was 45 degrees, and this was writing very well on here because it's 40, but anyway, to go backwards, you would divide by square root of 2 and get root 2 over 2 and root 2 over 2. So as people are building that big, what I don't like anymore, unit circle, they're doing opposite over hypotenuse and writing sine and cosine out next to the angle, like all around their circle. So do you see why they use a radius of 1? Because that means these are already reduced. We're not hung up on that in our class. What if the radius was 7? Okay? Then if that's a 45-degree angle, this would be 7 root 2 over 2. Are y'all okay with that from all the stuff I made you do at first? Okay? And then what would your sign be? Opposite over hypotenuse. Wouldn't the 7's cancel and you'd get root 2 over 2? So do y'all see that it doesn't matter how big that circle is. Sine, cosine, and tangent ratios are proportional. They're always the same. So we're not hung up on the unit circle, okay? But when you hear that word, that means it has a radius of 1. I just thought of that. Didn't really have anything to do with what I'm about to teach you. All right, so let's say if the radius here is 4. Be ready to be pleasantly surprised by what's going to happen here. And some years, gosh, it's boring.
Can you ask the tax people?
I need to, because I bet they can orient it, and I probably could.
It just seems
I
annoying
probably
to
could.
draw.
Yeah, it is. But it's so great to be able to record on. So I'm sure there's some sort of thing I could push in Notebook to maybe orient it, but I know how to do it on the Symposium. I don't know how to do it on this board. I'm thinking they may need to do it. Okay, so if I write right in the middle, I'm okay. So let's see if the radius, I don't want that circle. Just talking, not thinking about what I wanted to do. I don't want the 90-degree angles. I just want this on this really lopsided, ugly circle. And let's say it has a radius of 4.
Looks like a face.
Huh.
It does.
Okay. Really interesting when I use purple. From your seat, can you see the blue background,
Yeah,
the outline? Okay. Anyway, if the radius is 4, and a lot of years I actually, when I was in my own classroom, I had my tools at my own disposal, because at maybe every school but ours teachers teach in their own classroom instead of travel with you. But anyway, I would have like some string in my drawer, and I would pull out some string, and I would let them cut it to whatever size. I'd get a volunteer from the audience, like a magician, so that they could tell I wasn't like rigging this up just to make it work, okay? So I would say, anybody want to come cut this piece of string? And they'd come and cut it with the scissors that I had in my own classroom. And then I would take whatever they cut, and I would put it like real carefully and stretch it straight, and then go around and make a circle with the radius. Does that make sense? So pretend like that's just happened, that like Ava cut the string, and I just took whatever she got. And I put it right here, and I'll use string, you'll see why in a minute, and I wrap it around the circle, okay? I mean, you know how you can put a thumbtack in it and draw around the circle. So, in fact, I would usually have whiteboards in my room. I would usually tape the end of that ribbon up so that I could actually carefully do that. I could do it on a smartboard. Then I'll take, you know, like a magician, Ava's piece of string, okay? And then I would start to go, watch what I'm gonna do. I'm gonna start at 0, and I'm gonna start wrapping that string around my circle, okay? What is that string? It is the what of that circle. I'm going to start wrapping that radius around my circle, in which case then as people watch me, and I try to be really sly about it and act like everything's okay, and they start to feel sorry for me, okay? Which I really want to happen. Because you're like, oh, you know, I was Miss Newman back then. Miss Newman, she's so sweet. You feel so bad that this is going wrong for her. So some of you that I taught algebra to, you know, when I would cut up all those little things, get so excited about like an interactive thing, it would go awry really fast, and then I'd get everything passed down, it'd be wrong, and then class would be over, and anyway, so they were used to that. So they're like, here goes another one of her stupid examples. Sorry y'all missed out on that. Whenever Mr. Hill sees me cutting things and putting them in envelopes for like a hand zone, he's just like, don't even do it. Okay, so anyway, so I pick up the string and I start to wrap it around. So if you can imagine, this is pliable. That's why I use string, because I want to be able to wrap it around. So then I take that piece of string and I would wrap it and go one. That wouldn't be quite there. So try to, okay. All right, so try to help me visualize how big that would be if I actually took this. And I'll show you a better method in just a minute, a better example. So I'm trying to take that and wrap it around. It lands about right there. So that's one. Then I'll wrap some more because it's pliable, 2. Then I'll wrap some more, 3. And that's when they start to feel sorry for me, because they're like, oh, this is not really working out for her, because this is halfway around. And they probably thought that I wanted to think I was going to do some profound 1, 2, 3, right? So let's keep going. 4, 5, 6. I don't care what circle you give me. I don't care how big the radius is. I didn't care how big my student cut it back in the day. It always does that for the 9,000 years that I've been teaching. I have complete confidence in it. Let me show you a better animation of this. So when I open this, I think when I actually hit that, all of my emails are going to come up.
Just hold it.
There, okay. I don't think I have any super secret emails, but you know, it could be a parent going, I hate you. All right, so let's see. Pre-cal. Okay, topics.
You teachers get a lot of parents' emails?
No. I mean, maybe some do. Thank God I don't. All right, so no, hardly ever. Usually it's if they're like been sick for a long time and they're trying to help them coordinate things. But some, you know, I've heard horror stories. So anyway.
Oh no.
From
here at Marymount? Oh, I'm sure.
Yeah,
Sure.
you can only.
Yeah.
Okay, but this is on video, so let's watch. All right, so somebody has just gotten this radius, and now they're going to wrap it around. 1. One radius.
One rad. That's so rad.
Watch 2.
3
Wow. I don't think they're going to finish, but then there would go 4, 5, 6. Girls, that should just blow your mind. Okay, wait a second. Wait a second. Whoa, yes, hang on just a minute. Every time I do it, it goes 1, 2, 3. If I take the radius of a unique circle and go 1, 2, 3, it never quite makes it, and guess what that extra distance is? It's 3.14 pi. That had to freak people out when they first saw it. And so, anyway, let me show you this. I hope I have it. There's a really cool thing Miss Arkin found. I think this is the same thing I just showed you. Let's see if I can find, well, I probably would have put it in radian measure. Maybe I may have put it in my other pre-cal class. Let me see. Somebody made like a little 3D thing for it. Yeah, circle trig animation. Maybe, but y'all see here. Oh, here it is. All right, so somebody went in a fab lab, not at our school, but Miss Arkin has actually then gotten, I think, Mr. Deck to help her. She has one of these, like, down in the Math Center. Okay, ready?
Oh, I saw this.
Watch, girls, you don't want to miss this. So do you see they're verifying that that's the radius of the circle?
Yeah.
So it's like my string. They're going to start at 0, 1. Radius. They're verifying again that length is as big as the radius. So they're counting by the radius of that particular circle.
I think
it's just on repeat.
Yeah, it's just on repeat the
Yeah.
same.
And then we're gonna do something else. If they're just gonna keep doing that, it should last longer.
Look at all the comments.
Love
Yes.
this.
Love this.
Why is it not going further?
Because it's only
12
like
seconds.
yeah. Maybe there's another.
Oh, maybe I can click on
Mary Langmeyer says love this.
let's see.
Same Mary. Tragic tweet delete.
I bet you could just look it up on YouTube.
True.
Yang the goat.
What are we gonna call it?
Circles.
Jiao.
Oh well, that's the one we have. Somebody's cheating.
That's actually
So Fab Lab Radian thing.
Well, it says it was deleted. Maybe like the longer video was deleted because it looks like.
Did you see the longer one
Well, I've seen. Yeah, I saw the longer one. I don't know.
somewhere here?
on Twitter.
Wait. Okay,
Circle
Ken.
cut out.
It's 12 seconds, so
Yeah.
it's
You
just
look
gonna.
at the
keep-
hashtags.
All right.
I
So let me try
I
it.
think the original like video tweet was deleted. Maybe that tweet had the longer.
She said tragic tweet delete. In the description.
It said tragic tweet delete. I thought I'd lose that in bag.
Taken me.
That's really cool. That's satisfying to look at.
It is.
What happens? Oh.
It's math. It's okay.
Miss Arcan did all of this, but
You
now.
look at videos. You were looking at images.
Did I see? Just
If we
Google.
say math happens, British people say math happens.
Well, should I go to video? Where's
Yeah,
videos?
yeah,
Good
think
more.
about it.
That's a
More.
good question. You should make a TikTok about that.
That actually is a really good question. Great.
All right. So was it Math Happens? Is that what it was?
Yeah.
I thought it was what will happen.
But then also, this could have been the blog that it was posted.
Yeah. It could be just the user's name.
We're lost.
All right. So let me go to YouTube.
We got lost in the sauce.
Let's see.
Too much stuff.
Is there like a name for what this is?
We were swimming in the sauce.
It's Fab. Somebody went in the Fab Lab and made this like little radian circle.
Exactly.
I woke up at 12 today thinking it was 5 a.m.
Okay. I think you get the idea, though. Let me go.
Unit circle.
Oh, whoa, whoa, whoa! Did you see one? Oh, did you say maybe I should do that?
Yeah.
Should I
Let's see.
Did Mr. Jack put it on a social media platform?
It showed the whole thing last time I pulled it up. Let's see, FabPa, laser.
Me too. Laser cut unit circle. Okay.
Oh, well, I thought I spelled that wrong.
Fab lab at school.
I think you should, if you typed in laser cut unit circle.
Yeah, get rid of that. All right, so unit circle. But see, it may not be a unit circle. That's why I've kind of shied away from it. It could be bigger. Because unit means, but I think they did do a radius of 1. Okay, it's not really worth, I'll bring it up here sometime, but let's go back to this and just look at what's going to happen in this like aggravating little thing here. All right, so, all right, I'm going to pause it and pull it down. So then whoever's doing this is going to wrap it around and it's going to go 1, 2, and you see it's going to be 3, and it's still going to fall a little bit short of pi. It doesn't matter how we do it or when we do it or how many literally thousands of years we've done it. It happens every single time. Just a little philosophical thing, because you know you kind of can't help but get into some philosophy when you get into higher mathematics. And a lot of the great mathematicians were also great philosophers, like Aristotle, Louis Pascal, Archimedes, people like that. You just kind of can't start to think about how the world works without philosophizing about how that could happen. As a yeah, it's really, but I don't want to get too deep into it because of what we need to do today before we leave in the next few minutes. But when we call things irrational numbers, it's odd to me that those are the numbers that seem to matter in the real world. Like if you know E, 2.718, the golden ratio, 1.618, pi, 3.14, but all of those are rounded off numbers of something that never ends. They're irrational to us, but I'm guessing that they must make a whole lot of sense to our world and however it happened. I don't think 1, 2, 3, 4, 5 really works really well in our world. Think how shocked you are if you go to Duane Reade and buy a bunch of stuff and you get up to the cash register and they say that'll be $20 or $4. You go, and how much? You know, the only time you usually get an integer value is if you stopped at a fruit stand. Do y'all see what I mean? We're kind of shocked by those integer values, okay? So anyway, let's keep going. Let me show you what's happening. So it makes sense to call this 1 radian, 2 radians, 3 radians, but the one that makes the most sense to us would be this one, which would be 3.14 radians every single time, no matter how big the circle is. But why in the world in a math class of this caliber would I say 3.14 radians? Why wouldn't I just say, what? Pi, okay? So halfway around the circle, exactly halfway around is always pi radians. You may have noticed in the video then they said all the way around the circle is what? 2 pi. So I said my radius was 4. Get ready to have your mind blown, okay? So how far is this? In inches. Say this is 4 inches. The string is 4 inches. So how far is this? 4 inches. 4 inches. 4 inches. Oh, to right there. 4 inches. 4 inches. 4 inches. And a little bit more. 1, 2, 3, 4, 5, 6 times 4 is 24. But don't I have a little bit more? Yeah. Okay? So the circumference, Mia, of a circle is not 6 times the radius. I didn't quite get the circumference of that circle, did I? It's what times the radius?
Pi.
Okay, this is 1, 2.
Oh, 24.
No, hang on. It's more than 24, right, Julia?
Yeah.
Do you agree it's more than 24? Because I'd be through with my string and I'd have that little bit left.
Yes.
So if pi is 3.14, what is 2 pi?
2 pi.
Okay, no, wait, hang on, you're right. But don't, so just, pi is 3.14, what is 2 times that?
6.28.
This is 6.28 of those strings going around my circle. So instead of multiplying 6 times the radius, because then I would always not have the circumference, don't I need to go a little bit more?
Yeah.
I actually need to go 1, 2, 3, 4, 5, 6.28 times each radius to get the circumference of the circle. What did your teachers teach you the circumference of a circle was? What's the circumference of a circle?
2 pi.
They were working in radians. You should have raised your hands and gone, wait a minute, why are you teaching me the circumference? Isn't the circumference all the way around 360 degrees? They didn't use 360 degrees, they used radians. Because in radians, the radius is built into it. So watch again the circumference of a circle. So you've been using radians, pi r squared, 2 pi r, 4/3 pi r cubed. Guess what you've been working in all along? Radians, okay? So,
What?
and some of y'all started to see that, which is great. I can't find my... Oh, no.
Just put it on your hand.
Put it on your hand.
All right, so I'll just get just a plain white slide. All right, so look at this. If I want the circumference of this circle, okay, and this is the radius, it'll always go 1, 2, 3,
Oh, it does look like
The little weird.
4, 5, 6. So if this is 3, and I want to know how far around this circle is, 1, 2, 3, 4, 5, 6 of those 3s. Will that give me the circumference?
No.
I need how many of those 3s? I need 6.28 of those 3s, don't I? Do y'all see what I mean?
Yeah.
And instead of 6.28, I might as well write 2 pi times the what of that circle?
Radius.
Radius. Your teachers were teaching you radians. They were not giving you the circle in degrees. They did not say 360. Isn't that all the way around? Okay.
What I'm confused about is if there's, like the little slivers that are like extra,
The
there's
extra?
2 of those, and each of them are pi, then each of those are 3.14. But then wouldn't you just like add that to
Okay,
the
this
6,
halfway
and then it would be,
around,
like
this-
9 points?
No, good question. This is pi.
Yeah.
So let's just take the top half. This is 1, 2, 3.14. Okay? So
Wait.
this is pi times r so far. Alright, watch my r. 1, 2, 3.14, right?
So wouldn't that?
And then if I want the whole thing, couldn't I just double this?
Yeah, no, but what I'm confused about is pi is, like from there, it looks like pi is just 0.14.
Yeah, that's what I thought, but then it's like. it's
Halfway
how many times
around,
3
this
goes
is
into the
1,
first half.
2, 3,
Pi.
and a little bit more.
That's the 11.
This goes 1,
Yeah, but
2,
Pi isn't the
3.
same as how many times 3 fits in on that one half.
This is 1, 2, 3.
oh, so that's not
This
pi
is
is the
3.
size of the sliver.
So if I go all the way, it's 1, 2, 3.14. So the little sliver I think you're looking at is 0.14.
Yeah.
So that makes 3.14.
Okay, so I thought that you were saying that the little sliver was pi.
Yeah,
Not
that's
at
what
all.
I said.
That's-
that's
what
what
I
I
said.
thought.
Yeah.
Same.
We're going 1,
It's the little
2,
decimal point.
3, and it doesn't
Yeah.
quite stretch.
That's where the decimal
All the way halfway around is not 1, 2, 3 radiuses, it's 1, 2, 3.14 radii.
Wait, so the distance covered by those radii is the equivalent of pi.
Halfway around,
Halfway is pi.
halfway
And
is
then
pi.
the whole way is 2 pi.
Okay.
So
The whole.
if I take the radius, watch, girls, you're making it too hard.
I think
If I
I'm
take
confusing
the
myself.
radius, You go 1,
Mhm.
that's 1 radius.
Yeah.
2, that's 2 radii. 3, that's 3 radii. Well, how many radii is this then? 1, 2, 3, a little bit more. Guess how much more? That's 3. 4 is over here. What is this? 1, 2, 3.14 is right there. Maybe you aren't familiar enough with pi. Pi is 3.14.
Yeah.
1, 2, 3. This is halfway. I still gotta go a little bit more. It's a
Yeah.
little bit more
Yeah.
than 3 every time.
No, I understand that. I'm just the little space that
It's
that little-
0.14.
Okay, and then the rest is just there.
It's because 4 is way over here.
Got it.
Do
Okay.
y'all see what I mean? Okay,
Yeah.
so,
I just wasn't sure what. how much
Alena
that little
said
bit
what
was.
I'm driving to really hard here is that halfway around a circle in degrees is 180. In radians, it's pi. Okay? Pi means I'm measuring it with the radius of the circle, which is really why it's better. So what's all the way around the circle is twice that, 2 pi. So pi is equal to 180 degrees, and what's 2 pi equal to? 360. It's just like I was your language teacher, and I said, I don't even know what the word is. What's the word for pen in Spanish?
Lapis.
No, pluma.
That's a pencil. I lied.
So I could write it on the board. I could go,
Stilo.
pen equals whatever she just said. right? Y'all see what I mean? And you would start to learn a new language. And
I said lapis.
so our new language is radians, okay? So stay with me. Now we're about to do something else. Okay, girls, that's just, hey, shh, please listen. That's just like I told you 12 inches equals 1 foot. Okay? If Alex holds her hands up like this and tries to do 1 foot, Kate could go, I've got 12 inches. They're both right, but they're using a different unit of measurement, aren't they? She's using feet, you're using inches. Aren't they the exact same?
Yeah.
Okay. So what we're learning is we're gonna be fluent in radians. Right now you're pretty fluent in degrees, but I gotta get you fluent in radians, okay? So we're just gonna keep going till 250. So if this is, okay, so this is the radius. And just to recap, it goes 1 radius, 2 radians, 3 radians, and a little bit more. By the way, can y'all see 1 radian is a ton bigger than 1 degree.
Yes.
2 centimeters is a lot smaller than 2 inches, so that's okay. You should be okay with that. Kilometers, if you've run 40 kilometers, it's a lot different than having run about 20 or 25 miles, okay? Those are different numbers to say the same thing, but they're vastly different numbers, all right? 1 radian is very large. That's why, in case you've ever wondered, it matters what mode your calculator's in. The
Oh, yeah.
sine of 1 degree will be completely different than the sine of 1 radian. It would be like me going in a small town in France and trying to speak to people that don't know English, okay? It's completely different. I can yell at them all I want. You know, people start to talk louder thinking that you're all of a sudden gonna understand them, okay? And slower. Well, let me talk slower, then you'll understand, which I can hardly talk slower, but that's beside the point. Okay, so, we're talking in radians now, and this is pi radians, okay? So what is this?
4, 5.
This is pi. Remember 3.14 is halfway around?
1/2 pi.
That's half of pi, isn't it, Kate? So I
Oh,
took
yeah.
pi, half of that is pi over 2. So now we're gonna count around our circle if you could actually read that. That's pi over 2, okay? So this is 1 pi over 2, 2 pi over 2.
3 pi over 2.
This one down here we call 3 pi over 2. And then I get 1, 2, 3, 4. 4 pi over 2 is 2 pi. Every pi over 2 is worth how many degrees? Look at the picture.
90.
90. Did y'all see every time I count by a half of pi? And that also jives with this, doesn't it? If pi's 180, what should pi over 2 convert to in my new language? 90. Okay, so let's go to what Kate said, and let's look at pi over 4s. This will be the last thing I do right now. So what is this? I just took pi, I divided it in half, and then what did I divide those in? So what, that'd be pi over 4. So this is pi over 4. Guess how many degrees pi over 4 is? Look at the picture.
45.
45, isn't it? Okay. Y'all see that? It also fits with 180 divided by 4 because that's pi over 4 in my new language. All right, 1 pi over 4. How many do I have now? 2 pi over 4s. Is that pi over 2?
Yes.
3 pi over 4. 4 pi over 4? Is that okay? 5 pi over 4s. 6 pi over 4. Oh, I'm sorry, I'm going fast because it's time to go. But y'all see that 6 pi over 4?
Yeah.
7 pi over 4s. 1, 2, 3, 4, 5, 6, 7 pi over 4s. 8 pi over 4s. What's 8 pi over 4? 2 pi. Do you see how it's all going to fit?
Yeah.
So in the next class, we'll work on radians, and it looks like that I'm probably going to postpone your test because I want this to be on the test. So, I don't know what you have the week after Thanksgiving or possible. Will everybody be here the couple of days before Thanksgiving?
I don't know.
Yes.
Wait, so it's not gonna be next week, the week
Your
after?
test will not be on Wednesday. Oh, it could be on Friday. I'll let you know. Test will not be Wednesday. I want to get radians in. So,
then I might have to-
homework will be, some sort of work out of the book, where you're reviewing what you know in degrees, and all students take calculus, okay?
Also not this. This
You
is
won't have to
not-
do this. Oh, yeah, here.
Okay.
I'll just keep that for you, okay?
Thank you.
All right, so homework will be out of the book, and I'll post it soon, and it'll be reviewed, okay?
I still don't have physics.
So I'll look